Tonight, we're stepping into a version of Earth that almost existed. A world where the asteroid never struck, dinosaurs kept evolving, and humans may have never become the rulers of the planet. From giant predators to strange prehistoric ecosystems, this is a calm journey into one of the biggest what-if mysteries in Earth's history. Welcome to Sleepy Earth Channel. Before we begin, leave a comment below telling me what city you're watching from tonight, and whether you think humans could survive in a world still ruled by dinosaurs. 66 million years ago, the world came within moments of becoming something completely different. In the real history of Earth, a mountain-sized asteroid struck the Yucatan Peninsula with more force than billions of nuclear bombs, throwing fire, ash, and darkness across the planet and ending the reign of the dinosaurs forever. But tonight, imagine something slightly different. Imagine that asteroid arriving just a few minutes later. Imagine Earth already having moved enough in its orbit for the rock to miss entirely, silently passing through space where no living thing would ever notice it. No impact crater, no global firestorm, no years of darkness. And somewhere in the warm forests of the late Cretaceous, enormous creatures continue walking beneath the trees, completely unaware that extinction had almost found them. The strange thing is, this scenario is not fantasy in the way most people think. Scientists genuinely believe the survival of mammals, and eventually humans, depended heavily on that single event. Without it, Earth may never have belonged to us at all. At the end of the Cretaceous period, dinosaurs had already ruled the planet for over 160 million years. To put that into perspective, Tyrannosaurus rex lived closer in time to modern humans than it did to Stegosaurus. Entire mountain ranges rose and disappeared during the age of dinosaurs. Oceans opened and closed. Continents drifted apart. Through all of it, dinosaurs adapted again and again with astonishing success. Some became armored tanks covered in spikes. Others grew necks longer than buses. Some evolved feathers, advanced hunting vision, and brains surprisingly sophisticated for reptiles. By the final days before the asteroid, dinosaurs were not failing. That idea survived for decades in popular culture, but most paleontologists no longer see the extinction that way. Many dinosaur groups were thriving right up until the impact. Fossils from Western North America show complex ecosystems packed with predators, giant herbivores, flying reptiles, crocodilians, mammals, insects, and flowering plants spreading rapidly across the world. Earth was alive with movement. Dense forests stretched across humid coastal plains where duck-billed hadrosaurs moved in massive herds, stripping vegetation with beaks evolved almost like giant biological gardening tools. In the shadows nearby, young tyrannosaurs may have hunted smaller prey while adults dominated the top of the food chain with bone-crushing bites powerful enough to shatter skulls. Above them, pterosaurs with wingspans wider than small airplanes soared over inland seas, searching for fish and carcasses. And hidden beneath all of this, mammals still existed, but barely in the way we imagine them today. Most were small, nervous, nocturnal. They survived partly because they avoided direct competition with dinosaurs. Many lived underground or in trees, feeding on insects and seeds while the giants controlled the daylight world. If the asteroid never arrives, that balance may never change. It is difficult for the modern mind to fully understand how dominant dinosaurs truly were, because humans instinctively imagine ourselves at the center of Earth's story. But for most of the planet's history, mammals were not important. Dinosaurs occupied nearly every major ecological role on land for an unimaginably long time. Some scientists argue that mammals were already slowly diversifying before the extinction event, and that intelligence or social complexity may still have evolved eventually. But even then, the path would likely have been radically different. Primates may never have appeared at all. Human beings could simply be the accidental outcome of a temporary ecological opening created by catastrophe. That possibility changes the emotional feeling of history itself. It means civilization may not have been inevitable. It may have been unbelievably fragile from the beginning, and the dinosaurs, in a sense, almost never left. Birds are now widely accepted by scientists as living descendants of small feathered theropod dinosaurs. Every sparrow, hawk, raven, and eagle alive today carries part of that ancient lineage. The age of dinosaurs did not entirely end, it transformed. But if the extinction never happens, evolution continues on a completely different road. Feathered dinosaurs may spread even further across the planet. Some paleontologists suspect many species were already becoming more intelligent, more social, and more behaviorally complex near the end of the Cretaceous. Troodontids, for example, had relatively large brains compared to many earlier dinosaurs, and possessed forward-facing vision that suggests advanced hunting abilities. Over millions of additional years, could some dinosaur lineages have evolved intelligence approaching mammals? There is no scientific consensus on that question, but it continues to fascinate researchers because evolution repeatedly rewards problem-solving in unstable environments. In another Earth timeline, forests might eventually fill with highly intelligent pack-hunting dinosaurs communicating through calls, color displays, or feather movements impossible for us to imagine. Even climate itself may have changed differently in a dinosaur-dominated world. The late Cretaceous was warmer than modern Earth in many regions. Polar forests existed in areas now buried beneath ice. Sea levels were dramatically higher. Vast, shallow seas split continents apart. Dinosaurs were adapted to greenhouse conditions that modern humans would consider extreme. Some species even lived in polar environments with months of darkness each year, suggesting they were far more adaptable than older depictions of sluggish reptiles implied. Without the extinction event disrupting ecosystems worldwide, these evolutionary pressures continue uninterrupted. Giant herbivores may keep reshaping forests through migration patterns, resembling ecological engineering projects on a continental scale. Predator populations continue balancing entire ecosystems through fear alone, much like wolves affect modern Yellowstone, except on a scale almost impossible to comprehend. A single adult Tyrannosaurus rex weighed around 9 tons. Now imagine descendants evolving for another 66 million years. The truly unsettling part is realizing how small humans would appear inside such a world. Modern civilization depends on stability. Roads, farms, shipping routes, electrical grids, and cities all assume humans fully control large-scale land ecosystems. But a planet still dominated by megafaunal dinosaurs may never allow that level of control. Imagine trying to build early agriculture in river valleys, patrolled by territorial predators larger than elephants. Imagine ancient human ancestors attempting migration across landscapes where entire forests shake from the movement of massive herbivores. In our timeline, humans rose partly after Ice Age extinctions removed many giant competitors and predators. But in this alternate Earth, the giants never disappear. Intelligence alone may not guarantee dominance. That idea challenges one of humanity's deepest assumptions about itself. We often speak about evolution as though larger brains naturally lead towards civilization, technology, and mastery over nature. But evolution does not plan ahead. It only favors survival in the present moment. Dinosaurs survived successfully for over 160 million years without building cities or radios. From nature's perspective, they were already among the greatest success stories in Earth's history. Humanity, by comparison, has existed for only a tiny fraction of that time. There is another detail many people never realize about the asteroid impact itself. It was not merely the collision that caused extinction. It was where the asteroid struck. The rock hit a region rich in sulfur-containing rocks and sediments, launching enormous quantities of debris into the atmosphere. Global temperatures collapsed, photosynthesis failed, food chains broke apart. Some scientists believe that if the asteroid had struck another part of Earth, the extinction may have been far less severe. In other words, dinosaurs may have come terrifyingly close to surviving, even in our own timeline. Entire histories can depend on location, timing, and chance. Somewhere out in the darkness of the universe, there may be countless Earth-like worlds where no extinction ever came, where intelligent mammals never rose, where ancient reptilian dynasties still dominate continents beneath unfamiliar stars. As the final hours before the real impact approached, the dinosaurs themselves would have noticed nothing unusual. The forests still echoed with insects and distant calls. Rivers still carried sediment toward warm inland seas. Hatchlings still emerged from nests hidden beneath vegetation. Life continued with complete confidence in tomorrow. And perhaps that is what makes the story feel so haunting. Earth's entire future balanced on an event no creature could predict or understand. One ordinary day separated the world of dinosaurs from the world of humans. If that day changes by even a little, then everything after it changes too. Your city never exists. Human language never forms. No pyramids, no ancient empires, no satellites crossing the night sky. Somewhere in the deep, humid darkness of a prehistoric forest, something enormous still moves between the trees, and the age of dinosaurs simply continues without interruption, as though it was always meant to last forever. The most unsettling part about imagining a world where dinosaurs never went extinct is realizing they would not have stayed the same. Popular culture often freezes dinosaurs in time, as if evolution simply stopped with Tyrannosaurus rex and Triceratops standing permanently in some ancient swamp beneath volcanoes and dark red skies. But evolution never pauses. It constantly experiments, constantly reshapes, constantly removes what no longer works, and rewards whatever survives just a little better than everything else. If the extinction event never happened, the dinosaurs of 66 million years ago would likely look almost as strange to us as Cambrian sea creatures look today. Entire lineages would continue adapting across climates, continents, and ecological pressures for a span of time longer than the gap between the first human cities and the present day, multiplied thousands of times over. 2. In that alternate Earth, the age of dinosaurs does not remain prehistoric. It becomes modern. The first thing that changes is the image most people still carry in their heads. Many dinosaurs were probably far more active, colorful, and behaviorally complex than older movies once suggested. Over the past few decades, fossil discoveries have completely transformed scientific understanding of dinosaur appearance and behavior. Feathered dinosaurs are now well established through fossils found in places like northeastern China, where volcanic ash preserved microscopic details of feathers, skin, and body structures with extraordinary precision. Some small theropods looked less like giant lizards and more like predatory birds with tails and teeth. Even larger species may have displayed feathers during parts of their lives for warmth, camouflage, or visual signaling. In other words, evolution was already pushing some dinosaur groups toward forms that feel strangely modern before the asteroid ever appeared. And when evolution finds something effective, it tends to build upon it. Birds themselves became one of the most successful animal groups in Earth's history precisely because feathers opened possibilities far beyond flight. Feathers regulate temperature, attract mates, communicate social status, intimidate rivals, and protect offspring. Non-avian dinosaurs survive into the modern era. Those pressures continue shaping them in increasingly complex ways. Entire forests might eventually contain species with elaborate displays of color and sound rivaling tropical birds today, except attached to creatures the size of horses, trucks, or even buildings. Some paleontologists suspect visual communication among dinosaurs may already have been sophisticated near the end of the Cretaceous. Horns, crests, sails, and feather patterns may not simply have been random decoration. They could have served as social signals in crowded ecosystems where recognition and communication meant survival. Imagine what another 60 million years of refinement could produce. Terrifying predators of the Cretaceous may not remain giant forever either. One of evolution's most consistent patterns is flexibility. Large animals dominate certain environments extremely well, but they also require enormous energy. Environmental shifts repeatedly favor smaller, faster, more adaptable species. In our timeline, after the extinction event, mammals diversified rapidly into open ecological roles. But in this alternate world, dinosaurs themselves continue filling those niches. Some descendants of giant predators may shrink into agile pack hunters, optimized for forests and mountains. Others may evolve longer legs for endurance across dry plains. Some could even become semi-aquatic ambush hunters, similar to crocodiles, except with higher metabolisms and more active lifestyles. There is evidence certain dinosaur groups were already moving in that direction before extinction interrupted everything. Fossil trackways discovered across multiple continents suggest coordinated herd movement among herbivorous species, while bone beds containing numerous individuals hint at possible social structures in some carnivores as well. This matters because social behavior changes evolution dramatically. Social animals learn faster. They adapt through cooperation, not just physical traits. Wolves, dolphins, elephants, and primates all demonstrate how intelligence often grows alongside communication and group survival. Dinosaurs may not have followed the same path. Mammals did, but they were not evolutionary dead ends. Some were likely far more behaviorally advanced than the word reptile makes people imagine. One particularly fascinating example comes from a group called troodontids, too. These relatively small feathered theropods possessed unusually large brains compared to many other dinosaurs, especially in regions associated with sensory processing and coordination. Their eyes faced forward, giving them stereoscopic vision, useful for judging distance during hunting. Some scientists have speculated cautiously that if extinction never occurred, descendants of these animals might have evolved increasingly complex cognition over millions of years. In the 1980s, paleontologist Dale Russell even proposed a hypothetical creature nicknamed the Dinosauroid, imagining what a highly intelligent dinosaur descendant could look like. The concept remains controversial and highly speculative, but it reveals something important about how scientists now think about dinosaur potential. The old view of dinosaurs as biologically primitive has largely collapsed. They were dynamic animals participating in evolutionary experiments that extinction abruptly interrupted. And perhaps the strangest possibility is not giant. Predators becoming smart but smaller dinosaurs becoming invisible parts of everyday ecosystems, much like birds today. In this alternate Earth, cities, if intelligent mammals ever manage to build them at all, might constantly coexist with dinosaur descendants nesting on rooftops, stalking wetlands, or migrating across continents. Some may resemble giant flightless birds with razor-sharp claws adapted for urban scavenging. Others could fill ecological roles similar to deer, wolves, bears, or primates. The distinction between bird and dinosaur eventually becomes meaningless because evolution erases the boundary completely. Modern ecosystems would feel both familiar and deeply alien at the same time. Another factor often overlooked is climate. Dinosaurs evolved during one of the warmest extended periods in Earth's history. Atmospheric oxygen and carbon dioxide levels fluctuated differently than today. Sea levels were higher, and vast tropical environments stretched across regions now covered in snow or desert. Yet dinosaurs survived dramatic climate swings for millions of years. Some species even inhabited polar regions with seasonal darkness. Fossils discovered in Alaska and Antarctica suggest certain dinosaurs tolerated cold temperatures surprisingly well. This adaptability matters because it means dinosaurs were unlikely to remain trapped only in warm jungles forever. Over tens of millions of additional years, they may have spread into almost every environment on Earth. Imagine feathered predators hunting through snowy northern forests beneath auroras. Imagine armored herbivores crossing windswept tundra during migrations longer than anything seen among modern mammals. In a world without extinction, evolution keeps testing dinosaurs against every challenge the planet creates, and inevitably, some lineages succeed. There is also the uncomfortable possibility that dinosaurs may have prevented mammals from ever becoming dominant large animals at all. Mammals existed during the age of dinosaurs, but most remained relatively small for over 100 million years. Not because mammals were inferior, but because ecosystems were already occupied by highly successful reptilian competitors. The asteroid changed instantly by removing dominant species worldwide. Without that opening, mammals may never rise beyond limited ecological roles. Primates might remain tiny, nocturnal tree dwellers indefinitely, surviving cautiously in environments controlled by larger reptilian life. Human intelligence, tool use, agriculture, language, and civilization may depend entirely on dinosaurs disappearing first. That realization makes human existence feel strangely accidental. We often think of ourselves as nature's ultimate destination, But evolution has no destination. If one asteroid misses Earth, another branch of life continues instead. Some scientists even argue intelligence itself may not offer enough evolutionary advantage to guarantee technological civilization. Dinosaurs thrived for far longer than humans without ever building industry. In many ways, they may have been more sustainable than us. Their world remained biologically dominant across immense geological spans, while human civilization has already begun reshaping climate, oceans, forests, and extinction rates within only a few thousand years. In another timeline, perhaps Earth remains wilder, louder, and biologically richer, precisely because humans never become powerful enough to control it. The planet itself might look healthier from orbit, even while being far deadlier for any intelligent species trying to dominate it. And somewhere across that alternate Earth, descendants of creatures once hunted by Tyrannosaurus Rex continue evolving beneath changing skies, completely unaware of the strange truth hidden in their survival. Their existence depended on nothing more than a rock missing a planet by the smallest imaginable margin. No prophecy, no destiny, just silence in space where catastrophe never arrived, allowing the dinosaur age to continue unfolding into forms so strange and advanced that even the most terrifying creatures of the prehistoric world would eventually seem ancient by comparison. For most of Earth's history, mammals were background creatures. Small bodies moved quietly beneath roots, while enormous reptilian animals controlled the open world above them. That detail feels almost impossible to emotionally accept now, because humans instinctively see mammals as the natural rulers of the planet. We look at lions, whales, elephants, wolves, primates, and ourselves as though evolution was always moving toward this outcome. But if the dinosaurs never disappeared, the story of mammals may have remained trapped in darkness forever. In the warm forests of this alternate Earth, millions of years continue passing without the ecological collapse that once erased the dominant reptilian dynasties. The giant herbivores still flatten vegetation across floodplains. Predator calls still echo through ancient valleys at dusk. Feathered hunters continue evolving sharper senses, more efficient movement, more specialized behaviors. And somewhere beneath them, mammals continue surviving the way they always had, carefully, quietly, opportunistically. Fossils from the age of dinosaurs reveal something surprising about early mammals. They were not primitive failures waiting to become humans. Many were already remarkably adaptable. Some climbed trees, some burrowed underground, some glided between branches, some hunted insects at night with highly developed hearing and smell. There is even evidence that certain mammals preyed on small dinosaurs when given the chance. But adaptability alone does not guarantee dominance. Evolution rewards whatever works within existing ecosystems. And during the Mesozoic era, dinosaurs occupied most large ecological roles so successfully that mammals remained physically constrained for over 100 million years. This matters because body size changes everything in evolution. Larger animals gain access to different food sources, territories, defenses, and social structures. Bigger brains also require enormous energy. Intelligence is biologically expensive. Human brains consume extraordinary amounts of calories relative to body size, which means highly intelligent species usually evolve only when ecosystems consistently support those demands. In our timeline, the extinction event suddenly emptied entire planetary ecosystems. Large predators vanished, giant herbivores disappeared, forest structures changed, climate shifted violently. Mammals rapidly expanded into open niches because nothing else remained to stop them. But in this alternate world, those openings never appear. Dinosaurs continue controlling the daylight landscape, while mammals remain under pressure to stay small, hidden, and cautious. And over millions of years, survival strategies shape evolution far more powerfully than ambition ever could. Imagine forests where mammals become increasingly specialized for secrecy rather than expansion. Large eyes adapted for darkness, sensitive ears detecting distant footfalls of predators weighing several tons, compact bodies capable of vanishing into roots, cliffs, and tunnels within seconds. Some may evolve intelligence in subtle ways: memory, problem-solving, communication. But without opportunities to dominate ecosystems physically, those traits may never scale into civilization-building intelligence. There is an uncomfortable possibility hidden inside this idea. Human beings may not represent evolution's ultimate achievement at all. We may simply be what happens when a rare ecological vacuum appears long enough for one adaptable lineage to expand uncontested. Remove that vacuum, and the entire human future may disappear before it ever begins. One of the strongest clues comes from primates themselves. Early primates likely evolved partly because forests after the extinction event created new environments rich in fruit, branches, and complex three-dimensional movement. Forward-facing eyes, grasping hands, and larger brains became increasingly useful in those settings. But if dinosaur ecosystems remain dominant, those forest structures may evolve differently. Tree canopies could remain heavily occupied by feathered reptiles and gliding dinosaur descendants already optimized for aerial movement and visual hunting. Mammalian primates might never receive the evolutionary opportunities needed to expand beyond small nocturnal survival. In another timeline, the ancestors of humanity may spend millions of years as nervous, squirrel-sized animals hiding from creatures descended from raptors. Even climate may quietly work against mammalian dominance in this world. Mammals regulate body heat internally, which provides enormous advantages in cold and unstable environments. But much of the dinosaur era was warmer overall than modern Earth. Tropical and subtropical ecosystems stretched far wider across the planet. Dinosaurs themselves may have possessed metabolisms more active than older reptile comparisons once suggested, especially among theropods closely related to birds. That means mammals were not necessarily competing against sluggish, cold-blooded giants. They may have faced highly active, fast-moving animals already occupying many of the same adaptive pathways mammals would later exploit. In some ecosystems, dinosaurs could simply remain better suited for dominance. There is another possibility, even stranger than mammals never becoming dominant. Mammals might evolve intelligence without ever becoming physically powerful. Imagine a lineage of highly social, nocturnal mammals developing sophisticated communication, memory, and cooperation while still remaining physically vulnerable in dinosaur-controlled ecosystems. Intelligence under constant predatory pressure may evolve differently than human civilization did. Instead of open cities, agriculture, and large-scale settlement, survival could favor hidden societies, underground living, rapid movement, and extreme caution. Tool use may exist without industrialization. Communication may become advanced while architecture remains nearly invisible. Some evolutionary theorists argue intelligence does not automatically lead toward technology. Dolphins possess remarkable cognition, but never built civilizations because oceans prevent fire and metallurgy. Likewise, intelligent mammals in a dinosaur-dominated world may never gain the environmental stability needed for technological expansion. They could remain permanently trapped beneath larger forces they cannot control. And perhaps that is the most haunting possibility of all. Not that intelligence never appears, but that it appears and remains powerless. Modern humans often underestimate how difficult civilization actually was to achieve. Agriculture required relatively stable climates after the Ice Age. Permanent settlements required manageable predator pressures. Large-scale cooperation depended on surplus food and protected territory. Remove even one of those conditions and history changes dramatically. Now imagine trying to build early villages in landscapes containing predators larger than trucks with senses refined across millions of years of hunting. Human ancestors survived lions, saber-toothed cats, wolves, bears, and giant snakes, partly because those animals existed within ecosystems mammals already dominated. But in a world where dinosaur lineages continue evolving uninterrupted, predators themselves may become even more specialized, more intelligent, and more efficient over time. The balance between hunter and hunted could remain permanently tilted against mammals. Some paleontologists have suggested that mammals before the extinction event were already beginning to diversify in meaningful ways, and it is possible certain groups would eventually challenge dinosaur dominance regionally. Evolution rarely remains static forever. Climate changes, volcanic activity, continental drift, disease, and competition continuously reshape ecosystems. There may have been periods where mammals briefly expanded during local extinctions or environmental shifts. But brief expansion is very different from total planetary dominance. Dinosaurs had already proven astonishingly resilient across countless environmental changes long before the asteroid arrived. They survived volcanic catastrophes, fluctuating oceans, changing atmospheres, and shifting continents for over 160 million years. That level of evolutionary success suggests mammals may have struggled to ever fully replace them without a global reset event. And yet, despite all this, mammals possess one advantage difficult to ignore: flexibility. Mammals reproduce relatively quickly compared to giant reptiles. They care extensively for offspring. They learn behavior socially. They adapt diets and lifestyles rapidly. Rats survive in cities. Foxes thrive near suburbs. Primates manipulate environments creatively. Humans eventually walked on the moon. Evolution repeatedly shows that smaller adaptable animals often outlast larger dominant ones when environments become unstable. So perhaps the real answer is not simple domination by either side, but endless competition. A planet where dinosaurs remain physically dominant, while mammals slowly evolve pockets of intelligence, strategy, and adaptability across hidden ecological spaces. A world balanced between gigantic visible power and smaller invisible ingenuity. But even in that scenario, the timeline changes beyond recognition. No human empires rise when they did in our world. No agriculture emerges across ancient river valleys in the same way. No pyramids, no Roman roads, no industrial revolution, no satellites drifting quietly over Earth at night. Instead, Somewhere beneath immense prehistoric stars, mammals continue waiting in shadows, while the descendants of ancient dinosaurs keep ruling the visible world above them, unaware that in another universe, a single asteroid once gave mammals the opening to inherit the Earth. In the modern world, humans move through most landscapes with a quiet assumption that nothing larger or stronger truly controls them anymore. A person can walk across a parking lot at midnight, drive through deserts, hike through forests, or build cities beside rivers without constantly calculating whether some enormous predator is watching from the darkness. Even in dangerous places filled with bears, crocodiles, or big cats, humans remain the dominant force shaping the environment. But on a planet where dinosaurs never disappeared, that feeling may never exist at all. The world itself would feel fundamentally different, heavier, louder, and permanently alive, with the presence of creatures capable of killing almost anything around them. Not just isolated animals hidden deep in wilderness preserves, but giant predators woven directly into the structure of global ecosystems, the way storms, oceans, and mountains are today. And perhaps the strangest realization is that evolution would not preserve those predators as museum pieces from the Cretaceous. It would keep improving them. In our timeline, large mammalian predators like lions, wolves, and tigers evolved under enormous pressure to become efficient hunters. But they also evolved within ecosystems constrained by mammals themselves. Dinosaurs came from an entirely different evolutionary history. Many theropod predators already possessed bird-like lungs, powerful vision, rapid movement, and highly specialized hunting adaptations long before the asteroid struck. Some paleontologists now suspect certain species may have had metabolisms more active than traditional reptile elves, allowing them to sustain prolonged activity rather than behaving like sluggish ambush hunters. 2. If those evolutionary trends continue for another 66 million years, Earth may become home to predators unlike anything humans have ever encountered. Imagine descendants of dromaeosaurs, the group containing Velociraptor, evolving into highly coordinated pack hunters, occupying forests across multiple continents. Not giant movie monsters, but lean, intelligent animals optimized through millions of years of refinement. Their feathers provide camouflage in seasonal climates. Their communication becomes increasingly complex. Their hunting strategies evolve around memory, terrain, and cooperation. Fossil evidence already hints. Some dinosaur groups may have hunted socially, though scientists still debate how advanced those behaviors truly were. But social predation repeatedly appears across evolution because it works. Wolves developed it, orcas developed it, primates developed it. There is little reason to assume dinosaurs would stop evolving once they already possessed the physical tools for coordination and communication. And somewhere deeper in this alternate world, larger predators still exist too. Tyrannosaurs themselves may not survive unchanged, but their descendants could dominate broad ecological zones, much the way bears or big cats do today, except scaled upward into something far more intimidating. One overlooked detail about giant predators is the psychological effect they have on entire ecosystems. In Yellowstone National Park, wolves alter rivers simply by changing the behavior of prey animals. Deer avoid certain areas, vegetation recovers, erosion patterns shift, and entire food webs reorganize because predators create fear. Now imagine predators weighing several tons reshaping ecosystems across continents. Herds of herbivores migrate differently. Forests grow unevenly around hunting territories. Smaller species evolve nocturnal lifestyles simply to avoid detection. Entire landscapes become psychologically organized around avoiding death. And in that kind of world, mammals, including any human-like species, never experience the illusion of safety long enough to dominate the planet comfortably. Some regions may become nearly inaccessible. Dense tropical forests could hide ambush predators evolved specifically for concealment among giant ferns and humid wetlands. Open plains may belong to endurance hunters, capable of tracking prey over vast distances. Coastal estuaries could contain semi-aquatic dinosaur descendants, occupying roles somewhere between crocodiles, storks, and sharks. Even mountains may no longer offer reliable refuge if smaller feathered predators adapt to climbing rocky terrain and surviving colder climates. Fossils, discovered in places like Alaska, already suggest some dinosaurs tolerated snow and seasonal darkness surprisingly well. The old image of dinosaurs, confined only to hot jungles, no longer fits the evidence. Evolution would eventually spread them almost everywhere. Conditions allowed large animals to survive. Oceans may become even stranger. Marine reptiles like mosasaurs and plesiosaurs technically were not dinosaurs, but they vanished during the same extinction event. If the asteroid misses Earth, those lineages may continue evolving alongside surviving marine predators. Entire coastlines might become dangerous in ways modern humans can barely imagine. Massive, predatory reptiles could patrol shallow seas, while aerial descendants of pterosaurs scans coastlines from above. Fishing villages, shipping routes, and coastal cities. If human civilization ever reaches that stage at all, would face pressures unlike anything in recorded history. In our world, whales became some of the largest animals ever to exist, partly because marine ecosystems after the extinction event allowed mammals to expand into open niches. But in this alternate Earth, giant marine reptiles may keep those ecosystems under reptilian control indefinitely. And perhaps the most unsettling detail is that many of these creatures would not necessarily behave like simple, instinct-driven monsters. Birds today already demonstrate remarkable intelligence across multiple species. Ravens solve puzzles. Crows remember human faces for years. Parrots understand patterns and social interaction. These are living dinosaurs in a very real evolutionary sense. If non-avian dinosaur lineages continue evolving uninterrupted, some predators may develop levels of behavioral sophistication that feel disturbingly familiar. Hunting strategies may involve patience, communication, memory, and environmental manipulation. Predators surviving for millions of years often become experts at understanding fear itself. This changes the emotional structure of the planet. Human civilization developed partly because large predators gradually lost their ability to compete with organized humans using tools, fire, and cooperation. But on a dinosaur-dominated Earth, that balance may never fully tip toward mammals. Agriculture becomes difficult if giant herbivores devastate crops during migration seasons. Permanent settlements become vulnerable if predators view human populations as predictable food sources. Long-distance travel requires constant awareness of territorial hunting zones. Even fire may not guarantee safety against intelligent predators capable of adapting over generations to human defenses. In this world, wilderness never retreats completely. It remains enormous, active, and impossible to fully control. Some scientists argue that ecosystems containing giant predators are often healthier and more balanced because apex hunters regulate overpopulation and maintain biodiversity. In that sense, a dinosaur-dominated Earth may actually remain ecologically richer than the modern human world. Forests could stretch farther. Rivers may remain cleaner. Extinctions rates might stay lower without industrial expansion. But this ecological richness comes with a brutal trade-off. Humans, or any intelligent mammals, would no longer sit comfortably outside the food chain. Modern civilization depends heavily on removing uncertainty from daily life. Dinosaurs would put uncertainty back into everything. There is also a deeper evolutionary tension hiding beneath this scenario. Large predators themselves are often vulnerable to environmental collapse because they require enormous territories and food supplies. Throughout Earth's history, apex hunters repeatedly disappear when ecosystems destabilize. But dinosaurs survived for over 160 million years precisely because they diversified so successfully. Some remained gigantic. Others became smaller and highly adaptable. Some evolved flight. Some likely evolved insulation and active metabolisms. Their survival strategy was not size alone. It was flexibility across entire planetary systems. In another timeline, predator lineages may continuously split into specialized forms adapted for forests, grasslands, wetlands, mountains, polar regions, and coastlines all at once. A world ruled by predators does not necessarily mean every creature becomes huge. It means predation itself becomes one of the central forces shaping civilization, movement, architecture, and survival. Imagine ancient intelligent mammals eventually learning to build hidden settlements rather than open cities. Underground tunnel systems, elevated structures beyond the reach of giant hunters. Migration patterns designed around avoiding seasonal predator routes. Entire mythologies centered on creatures powerful enough to erase villages overnight. Humanity's relationship with nature would become deeply humbling because nature would remain visibly stronger. In our timeline, humans gradually transformed predators into endangered species. In theirs, predators may continue defining the boundaries of human existence indefinitely. And somewhere beneath endless prehistoric stars, across forests vibrating with distant calls and heavy footsteps, the descendants of ancient hunters continue evolving through darkness and moonlight, inheriting a planet that never stopped belonging to them. The world of the dinosaurs was not just different because of the creatures walking across it. The planet itself felt different. The air, the oceans, the forests, even the shape of the continents created an Earth that would seem almost alien to modern humans if we could stand inside it for a single day. And if the extinction event never happened, that climate system may have continued evolving along a path where dinosaurs remained perfectly adapted while mammals, especially humans, struggled to keep up. One of the biggest misconceptions about prehistoric Earth is the idea that dinosaurs lived in a single endless jungle beneath constant volcanic skies. In reality, the Mesozoic era lasted over 180 million years, and climates changed repeatedly across that immense span of time. Some regions were humid and tropical, others dry and seasonal, and toward the later periods, there were even cooler forests near the poles. But overall, Earth during much of the dinosaur age was significantly warmer than it is today. There were long stretches where permanent polar ice barely existed or disappeared entirely. Sea levels rose hundreds of feet higher than modern coastlines. Vast inland seas cut through continents, turning places like North America into partially submerged landscapes divided by warm, shallow waters filled with marine reptiles and ancient fish. If you looked at Earth from orbit during parts of the late Cretaceous, the colors themselves may have appeared different. More green, stretching toward high latitudes, fewer bright white polar caps reflecting sunlight into space, more humidity swirling through the atmosphere, more storms feeding enormous ecosystems, and perhaps, most importantly, a much more biologically productive planet in many regions. Dinosaurs thrived in these conditions, partly because warm climates support large-scale ecosystems exceptionally well. Longer growing seasons create more vegetation. More vegetation supports larger herbivores. Larger herbivores support larger predators. Entire food chains expand upward together. In our modern world, elephants and whales seem enormous to us because few land animals remain comparable in size. But during the dinosaur age, gigantic body plans evolved repeatedly across multiple lineages because Earth itself could sustain them. Some sauropods grew longer than basketball courts and weighed more than modern airplanes. They survived not through brute force alone, but because entire ecosystems continuously produced enough plant life to feed them. Now, imagine those evolutionary systems continuing uninterrupted for another 66 million years. In this alternate Earth, dinosaurs are not relics surviving against environmental change. They remain fully integrated into planetary climate cycles. Their migrations shape forests. Their feeding patterns influence vegetation distribution. Massive herds crossing continents alter landscapes the way glaciers or rivers do. Even today, large animals strongly affect ecosystems through what scientists sometimes call ecosystem engineering. Elephants knock down trees, whales redistribute nutrients through oceans, and grazing animals reshape grasslands. Dinosaurs operating on even larger scales could influence entire climate systems indirectly over geological time. Some researchers have even explored the idea that enormous sauropods may have affected atmospheric chemistry through methane production, though the scale and significance remain debated. The important point is that giant life forms do not merely live inside climates. They help shape them. There is another detail about the dinosaur world that feels strangely unsettling to modern humans. The atmosphere itself may have felt heavier and wetter in many places. Higher carbon dioxide levels likely contributed to warmer global temperatures across long stretches of the Mesozoic. Dense forests stretched into regions now frozen or dry. Storm systems may have carried extraordinary amounts of rainfall across superheated oceans. In some prehistoric environments, plants grew at astonishing rates under warm greenhouse conditions. Ferns, conifers, cycads, and flowering plants spread across landscapes filled with insects, reptiles, and amphibians thriving in heat and humidity. If this climate trajectory continues without the extinction event disrupting ecosystems, Earth may gradually stabilize into a permanently warmer, dinosaur-friendly world. Humans often imagine warm climates as pleasant tropical paradises, but sustained planetary warmth creates instability too. Stronger storms, expanding coastlines, flooded lowlands, massive seasonal rainfall shifts. In our timeline, humans built civilization during a relatively unusual period of climatic stability. After the last ice age, agriculture depended on predictable seasons. Cities depended on stable coastlines and manageable ecosystems. But in a greenhouse Earth dominated by dinosaur-adapted ecologies, those conditions may never fully emerge. Entire human civilizations, if they appear at all, would need to survive on a planet far less predictable than the one we inherited. And the dinosaurs themselves would continue adapting alongside those changing climates. Fossils found in polar regions already challenge older assumptions that dinosaurs could survive only in tropical heat. In Alaska, paleontologists discovered evidence that some species remained year-round residents rather than migrating south during dark winters. Ancient Antarctica, now buried beneath miles of ice, once supported forests where dinosaurs walked beneath seasonal darkness. This matters because it means dinosaurs were likely far more flexible than people once imagined. Feathers, insulation, social behavior, and active metabolisms may have allowed certain groups to expand into colder climates long before extinction interrupted their evolution. In another 66 million years, entirely new cold-adapted dinosaur lineages may dominate northern forests and mountain ranges. Imagine snow-covered valleys where feathered predators move silently through pine forests beneath glowing auroras. Imagine enormous herbivores crossing frozen tundra while steam rises from their bodies in sub-zero air. Evolution would not freeze dinosaurs inside ancient tropical stereotypes. It would keep reshaping them into whatever Earth demanded next, and Earth itself never stops changing. Continental drift alone would slowly transform migration routes, oceans, and weather systems over millions of years. The Atlantic Ocean continues widening even now. Mountains rise and erode. Ocean currents shift. These planetary changes repeatedly reorganize climates and ecosystems. Dinosaurs, surviving through all of it, would likely diversify into forms increasingly specialized for regional conditions. Some lineages may become desert-adapted endurance walkers, surviving heat extremes across enormous dry interiors. Others evolve in rain-soaked forests where visibility remains low and communication relies more on sound than sight. Some coastal predators may adapt to hurricane-prone environments, where survival depends on sensing storms long before they arrive. Modern animals already display astonishing environmental sensitivity. Birds detect atmospheric pressure changes. Sharks sense electrical signals. Elephants communicate through low-frequency vibrations, traveling across miles of ground. Dinosaur descendants, evolving over tens of millions of additional years, may develop sensory worlds almost impossible for humans to imagine. There is also the question of oxygen. Popular culture often exaggerates prehistoric oxygen levels, but atmospheric composition has fluctuated dramatically throughout Earth's history. During some ancient periods before dinosaurs, oxygen concentrations may indeed have been higher than today, supporting giant insects and unusual ecosystems. By the late Cretaceous, oxygen was likely closer to modern ranges, though still variable over time. In a dinosaur-dominated future, changing atmospheric chemistry combined with climate shifts may continue influencing body size, metabolism, and ecosystem structure in unpredictable ways. Giant animals require enormous oxygen and energy demands. But if ecosystems remain productive enough, evolution repeatedly finds ways to support gigantism because size itself offers advantages: defense, migration efficiency, thermal stability, and dominance over territory. The The result is a world where nature feels physically larger, louder storms, taller forests, bigger migrations, more powerful predators, and perhaps fewer safe places for smaller, intelligent mammals trying to establish permanent control. That may ultimately be the defining emotional difference between the human world and the dinosaur world. Modern civilization depends on reducing nature into something manageable. Roads cut through forests, rivers become controlled by dams, dangerous animals retreat into reserves, climate itself becomes something. Humans believe they can measure, predict, and eventually engineer. But on a planet where dinosaur ecosystems remain dominant beneath a warmer and more unstable atmosphere, nature never shrinks enough for humans to feel fully in charge. The world stays vast, wild, physically overwhelming, and somewhere beneath thick prehistoric clouds, drifting across ancient coastlines, thunder rolls through forests, filled with creatures perfectly adapted to a climate. Humans may never truly survive comfortably inside, because the Earth that shaped dinosaurs was never really designed for us in the first place. The idea that dinosaurs might one day have become intelligent enough to rival humans sounds at first like a pure science fiction, the kind of late-night thought experiment people imagine after watching movies filled with futuristic reptiles and lost worlds hidden beneath jungles. But the deeper scientists studied dinosaurs over the last few decades, the more complicated the question became. Not because paleontologists suddenly believed dinosaurs were secretly building civilizations, but because many of the assumptions people once held about intelligence itself started falling apart. For a long time, dinosaurs were portrayed as evolutionary dead ends, oversized reptiles driven almost entirely by instinct, too slow or primitive to compete once the environment changed. That image has faded dramatically. Modern fossil discoveries now paint a very different picture. Some dinosaurs were fast, some hunted in coordinated ways, some cared for nests and offspring, some possessed sharp senses, complex movement, and brains proportionally larger than scientists once expected. And once you accept that intelligence can evolve gradually over immense spans of time, another unsettling thought quietly appears behind it. If the extinction never happened, evolution would have kept going. Somewhere deep in those ancient ecosystems, certain dinosaur lineages may have continued moving toward forms of cognition far more sophisticated than anything the prehistoric world ever had the chance to fully develop. One group appears repeatedly in these discussions: the troodontids. They were relatively small feathered theropods, lightly built predators with large forward-facing eyes and unusually high brain-to-body ratios compared to many other dinosaurs. Fossils suggest they possessed keen vision and agile movement, traits often associated with active hunting behavior. Their brains were still nowhere near human complexity, but among non-avian dinosaurs, they stood out. In the 1980s, Canadian paleontologist Dale Russell explored a speculative idea that became strangely famous in scientific culture. He imagined what descendants of troodontids might look like if they continued evolving intelligence for tens of millions of years. The hypothetical creature, later nicknamed the Dinosauroid, had large eyes, grasping hands, and an upright posture vaguely resembling a human silhouette. Many scientists criticized the reconstruction because it reflected too much human anatomy, projecting our own evolutionary path onto entirely different animals. But the deeper significance of the idea was never the exact appearance. It was the realization that intelligence itself may not belong exclusively to mammals. Evolution repeatedly experiments with problem solving because survival rewards it under certain conditions. Crows solve multi-step puzzles. Octopuses manipulate objects and escape containers. Dolphins understand social complexity. Primates develop tool use and symbolic communication. None of these lineages are closely related in evolutionary terms, yet intelligence emerged independently because nature constantly tests new ways of interacting with the environment. Dinosaurs may have been participating in those same experiments before the asteroid ended them abruptly. And perhaps the strangest evidence comes from animals still alive today. Birds are living dinosaurs. That is no longer controversial science, and birds display forms of intelligence that often surprise even researchers studying them. Ravens remember individual human faces for years and communicate danger information socially across groups. Crows create tools from branches and wire. Some parrots understand numerical concepts and pattern recognition. Certain birds even plan for future events rather than reacting only in the present moment. These abilities evolved from dinosaur ancestry, which raises a fascinating possibility. If relatively small bird brains can already reduce remarkable cognition, what might happen across another 66 million years of uninterrupted dinosaur evolution? Intelligence does not necessarily mean human-like civilization, but it could mean ecosystems filled with creatures capable of strategy, memory, communication, and environmental understanding, far beyond what we normally associate with reptiles. One of the most important factors behind intelligence is social behavior. Animals living in groups often face enormous cognitive demands. They must recognize individuals, navigate hierarchies, cooperate during hunting, defend offspring, and respond to constantly changing situations. Mammals like wolves, elephants, and primates evolved increasingly complex brains, partly because social survival rewards flexible thinking. Dinosaurs may have been moving along similar pathways in certain lineages. Fossilized nesting grounds suggest some species cared for offspring in organized colonies. Trackways preserved in ancient sediments hint at herd movement and coordinated migration. Bone beds containing multiple predators together raise ongoing debates about whether some theropods hunted socially or merely gathered opportunistically around food. Scientists still disagree on many details because behavior fossilizes poorly, but the evidence increasingly suggests dinosaurs were not simple, solitary creatures wandering through prehistoric landscapes on instinct alone. They were dynamic animals responding to complex ecosystems. If those ecosystems continue existing for tens of millions of additional years, natural selection may repeatedly favor improved communication and adaptability. And intelligence itself often begins not with technology, but with survival under pressure. Predators must predict prey movement. Prey animals must anticipate danger. Climatic instability rewards flexibility. Competition rewards learning. Over enough time, evolution sometimes turns these pressures into cognition capable of reshaping entire ecosystems. Yet, there is an equally important caution hidden inside this speculation. Intelligence is not inevitable. Human beings often imagine evolution as a staircase leading upward toward civilization, because we are judging history from the perspective of the species that happened to survive. But nature does not move toward goals. Dinosaurs dominated Earth successfully for over 160 million years without inventing agriculture, mathematics, or engines. From an evolutionary perspective, they were already extraordinarily successful. Intelligence only evolves when its advantages outweigh its costs, and large brains are incredibly expensive biologically. Human brains consume enormous amounts of energy. Maintaining advanced cognition requires stable food supplies, long developmental periods, and social structures capable of supporting learning. Some scientists argue that human-level intelligence may actually be extremely rare because the conditions supporting it are unusually fragile. Dinosaurs may have continued thriving perfectly well without ever developing anything resembling civilization. But even without human-like technology, highly intelligent dinosaurs could still transform the emotional structure of the planet completely. Imagine forests inhabited by descendants of feathered theropods capable of coordinated communication rivaling wolves or dolphins. Imagine predators that remember migration routes, recognize patterns, teach behaviors socially, and adapt rapidly to environmental changes. In our world, humans became dominant partly because no other large predators could match our flexibility once tools, language, and cooperation advanced far enough. But on a dinosaur Earth, intelligence itself may become distributed across multiple lineages at once. Not one civilization ruling the planet, but networks of highly adaptive species shaping ecosystems through behavior alone. And if mammals remain physically marginalized in this alternate timeline, intelligent dinosaurs may continue occupying the ecological center of the world indefinitely. There is another detail that makes this possibility feel strangely haunting. Dinosaurs already survived far longer than humans have existed. Humanity's entire recorded history covers only a tiny fraction of dinosaur evolutionary time. If a few dinosaur lineages began developing increasingly advanced cognition before extinction, then the asteroid may have interrupted experiments already underway inside Earth's ecosystems. Not guaranteed futures, not hidden civilizations, but possibilities. Evolutionary roads suddenly erased before they fully unfolded. Somewhere in another version of Earth, where the asteroid missed, those roads continue forward into darkness. Humans never witness. Some may fail. Others may produce creatures capable of astonishing adaptation. Perhaps certain species develop symbolic communication through sound or feather displays. Perhaps some begin using primitive tools. Perhaps others evolve entirely different forms of intelligence. Humans would barely recognize because they emerged from reptilian and avian sensory worlds instead of mammalian ones. Intelligence shaped by motion vision, atmospheric sensitivity, and migratory memory, rather than human hands and spoken language. Truly difficult thing is realizing we may never know how close dinosaurs actually were to those possibilities. Fossils preserve bones, teeth, and footprints, but rarely thoughts. The asteroid ended the experiment before evolution revealed where those lineages might eventually lead. And tonight, beneath the quiet modern sky of a world inherited by mammals, it is unsettling to imagine another Earth still echoing with calls from creatures whose descendants may now watch the planet with minds growing sharper across millions of uninterrupted years, evolving not toward becoming human, but toward becoming something entirely their own. If humans somehow emerged in a world where dinosaurs never disappeared, survival itself would feel completely different from anything our species has ever known. Modern people often imagine prehistoric danger through movies filled with dramatic chases and roaring monsters, but real survival pressure works in quieter and far more exhausting ways. It changes where a species sleeps, how it moves, when it eats, how far it dares to travel, and whether it can ever relax long enough to build something permanent. In our world, humans gradually became the dominant large animal because intelligence, cooperation, and tool use allowed us to overcome predators that once terrified our ancestors. But in a dinosaur-dominated Earth, those advantages may never become overwhelming enough to tip the balance fully in humanity's favor. Instead of inheriting the planet, humans might spend their entire evolutionary history negotiating with creatures physically stronger, ecologically established, and perfectly adapted to environments. Humans would struggle to control. The first challenge would simply be staying alive long enough to evolve into anything recognizable as human civilization. Early hominins survived in Africa, partly because they developed cooperation, endurance walking, and tool use in ecosystems filled with mammalian predators they could eventually outsmart. Lions, hyenas, saber-toothed cats, and giant snakes were dangerous, but they belonged to ecological systems mammals already understood. Dinosaurs represent a different scale of pressure entirely. Many theropods evolved as highly specialized predators over immense evolutionary periods. Their senses, mobility, and hunting strategies may continue improving across tens of millions of years in ways difficult for mammals to counter consistently. A human ancestor moving through tall vegetation in this alternate world might face predators capable of detecting movement instantly from enormous distances, communicating socially across hunting groups, or navigating terrain with frightening speed and coordination. Under that level of pressure, humans may never become confident daytime hunters at all. Some scientists believe early mammals during the dinosaur era survived largely because they occupied nighttime ecological niches avoided by many large predators. If that pattern continues, human ancestors may evolve as cautious nocturnal primates rather than bold daytime walkers. Large forward-facing eyes, exceptional hearing, silent movement through dense forests. Survival built around avoiding attention rather than controlling territory. Intelligence under these conditions develops differently. Instead of expanding openly into grasslands and river valleys, human-like species may cluster inside hidden environments difficult for giant predators to enter. Caves, cliffs, dense forests, small islands, mountain regions, underground tunnel systems. Civilization itself, if it ever forms, may emerge not as a display of dominance, but as architecture designed entirely around concealment and defense. Imagine ancient human settlements built beneath stone overhangs with narrow entrances, impossible for massive predators to cross. Fires kept low to avoid attracting attention across valleys at night. Communication based on silence and distance. Migration routes carefully memorized around predator territories passed down through generations like sacred geography. In this world, survival knowledge becomes more important than expansion. The people who live longest are not necessarily the strongest, but the ones who understand the patterns of the creatures above them. There is a strange possibility that humans might become extraordinarily intelligent precisely because of constant danger. Evolution often sharpens cognition in environments where mistakes are deadly. Humans already possess remarkable pattern recognition, partly because our ancestors survived by noticing subtle details. Tracks in dirt, movement in grass, unusual sounds in darkness. A dinosaur world may intensify those pressures dramatically. Reading the environment becomes everything. Entire cultures could revolve around interpreting distant calls, migration rhythms, weather patterns, and predator behavior. Children might learn survival routes before language fully develops. Memory becomes essential because forgetting one dangerous location could mean extinction for entire groups. Yet intelligence alone does not solve the deeper problem. Civilization requires stability. Agriculture requires land that can be defended. Permanent settlements require predictable ecosystems, and giant dinosaurs would make both incredibly difficult. Imagine trying to grow crops in valleys periodically crossed by migrating herbivores weighing dozens of tons. Modern elephants already devastate farms, accidentally simply by moving through them. Now scale that upward into creatures far larger, moving in enormous herds across ancient migration paths older than humanity itself. Human agriculture may fail repeatedly because ecosystems remain physically dominated by animals too large to stop. Fences become meaningless. Early villages become temporary by necessity. Entire societies may remain nomadic for tens of thousands of years because permanent settlement attracts predators and herbivores alike. Even technology develops differently under those conditions. In our world, humans eventually gain dominance through metallurgy, organized warfare, agriculture, and industrialization. But industrial civilization depends on secure infrastructure, roads, mines, supply routes, permanent cities, stable coastlines, predictable seasons. Dinosaur ecosystems could destabilize every one of those assumptions. Transporting goods through predator territories becomes dangerous. Expanding cities into wilderness triggers ecological conflict constantly. Construction projects may collapse under migration pressure from giant animals. Humanity's relationship with nature stays tense because nature never retreats fully from the landscape. Some regions of Earth might remain permanently inaccessible to humans no matter how advanced they become. Vast prehistoric forests controlled by apex predators, swamps occupied by semi-aquatic hunters, mountain passes dominated by territorial carnivores adapted to cold climates. Even if humans eventually develop advanced tools, population expansion could remain slow simply because ecosystems continue resisting human control physically and biologically. And perhaps most unsettling of all, dinosaurs themselves may continue evolving alongside humans. Predators exposed to human behavior over thousands or millions of years could gradually adapt to human defenses. In our world, animals already learn astonishing things about us. Urban crows recognize traffic patterns. Wolves avoid hunting zones. Big cats learn human routines near villages. Now imagine highly intelligent dinosaur descendants observing human movement across evolutionary timescales. Some may learn to exploit roads, settlements, migration routes, or agricultural areas. Others may become increasingly nocturnal or stealth-oriented in response to human weapons. The struggle between humans and predators could become an endless evolutionary arms race where neither side ever fully wins. There is another possibility, even stranger than constant conflict. Humans and certain smaller dinosaur descendants may partially coexist. Not peacefully in the modern sense, but through complicated ecological adaptation. Some species may become tolerated scavengers around settlements. Others could serve symbolic or spiritual roles inside human cultures. Ancient myths in our world often describe dragons, giant birds, serpent gods, and intelligent beast-like creatures. In a dinosaur world, those myths may emerge from real encounters with surviving reptilian species powerful enough to shape human psychology permanently. Religion, architecture, and social structure might all develop around fear and respect for creatures. Humans can never entirely eliminate. Entire civilizations may define themselves by how they survive nearby predator populations, rather than by territorial expansion alone. And still, despite all of these obstacles, humans might survive. That possibility matters, because our species possesses one unusual advantage beyond intelligence itself: adaptability. Humans survive deserts, mountains, Arctic cold, islands, forests, and cities because culture evolves faster than biology. Tools, cooperation, memory, and storytelling allow people to adapt to environments that should kill them. In another Earth timeline, humanity may become smaller in population, but sharper in awareness, less dominant, but perhaps more connected to ecological reality. People may never believe they own the planet, because the planet visibly belongs to something larger. The emotional feeling of existence changes completely when humans are no longer the unquestioned apex species. Fear becomes permanent background awareness rather than rare emergency. Night sounds matter, distant movement matters, weather matters, wilderness remains enormous and unconquered. And somewhere beyond the reach of hidden human settlements, beneath ancient forests, trembling in heavy rain and moonlight, giant predators continue moving through the darkness as they always have, reminding humanity every single day that survival was never guaranteed in a world that never stopped belonging to the dinosaurs. If humans and dinosaurs truly shared the same world, history itself would feel almost unrecognizable. Not just because giant creatures still walked the earth, but because every human belief about nature, danger, power, religion, architecture, and survival would form under the constant presence of animals capable of overwhelming entire communities. In our timeline, humans eventually transformed dangerous predators into myths, symbols, and distant memories. Dragons became legends because no real creature alive could fully match the fear ancient people imagined. But in a world where dinosaurs survived, dragons may never become mythology at all. They would remain part of ordinary reality. Children would grow up hearing distant calls echo through forests at night, knowing those sounds belonged to living creatures large enough to tear apart homes, destroy crops, or erase travelers from the wilderness without a trace. Human civilization would not develop beside nature as its master. It would develop inside nature like something trying carefully not to be noticed. First human settlements might appear only in places naturally protected from large predators. Cliffs overlooking narrow valleys, islands separated by dangerous currents, caves hidden within mountain systems, too difficult for giant animals to enter. Early villages would likely prioritize visibility above all else. Towers, fire systems, elevated platforms, and lookout structures may appear long before decorative monuments or large palaces. In our world, many ancient civilizations built walls mainly against other humans. In theirs, walls may first exist to stop things much older and larger than humanity itself. And even then, walls would not always work. A migrating herd of multi-ton herbivores could flatten primitive settlements accidentally. Predators, learning human routines, may stalk travel routes and hunting grounds seasonally. Entire cultures could organize themselves around avoiding ancient migration paths passed down across generations. The way coastal societies remember storms or floods. There is a powerful psychological effect when humans are not the largest intelligence shaping the environment. Modern people move through most landscapes, assuming danger is temporary and controllable. But in this alternate Earth, wilderness remains permanently active. Forests are not peaceful places for reflection. Rivers are not simply resources. Darkness itself becomes meaningful again. Because humans know something larger may already be moving through it. Religion in such a world would almost certainly evolve differently. Ancient gods in our timeline often reflected forces humans feared but could not control: storms, oceans, disease, famine, predators. Now imagine civilizations forming beneath the constant presence of giant reptilian creatures surviving from deep time itself. Some dinosaur species may become symbols of divine power, destruction, fertility, death, or cosmic endurance. Massive feathered predators who, appearing through fog at dawn, may feel supernatural to early humans, even when fully understood as real animals. Temples could rise near fossil-rich cliffs, where ancient bones are mistaken for sacred remains of immortal creatures. Entire mythologies may emerge around seasonal migrations, eclipses linked to predator behavior, or enormous nests discovered in isolated wilderness. And unlike dragons in our own myths, these creatures would not stay trapped inside stories. They would still exist beyond the edge of the firelight. There is also the possibility that humans attempt something even stranger: coexistence through domestication. At first, the idea sounds absurd. Humans never domesticated large predators like lions or bears successfully on civilization-wide scales, because dangerous carnivores are difficult to control and expensive to feed. But humans did domesticate birds, themselves living dinosaurs. Chickens descend from wild jungle fowl. Falcons hunt alongside people. Ostriches and emus can tolerate managed environments despite remaining powerful animals. In another evolutionary timeline, perhaps certain small dinosaur descendants prove intelligent enough or social enough for partial domestication. Not giant apex predators, but mid-sized omnivorous species adapted for transport, guarding territory, hunting, or communication. Entire cultures may evolve alongside feathered dinosaur descendants, much the way horses transformed human civilization in our world. The line between animal and partner could blur in ways impossible to predict. Yet even if some species become integrated into human society, larger dinosaur lineages would still dominate the emotional background of civilization itself. Roads may never cross certain territories. Vast regions could remain biologically controlled by creatures humans simply learn not to challenge directly. In our world, humanity eventually mapped nearly every continent. In theirs, entire forests and wetlands may remain unexplored for centuries because entering them means disappearing. Exploration itself becomes sacred and terrifying. Travelers crossing prehistoric wilderness may carry detailed knowledge of sounds, scents, migration patterns, and seasonal dangers, the way sailors once memorized storms and currents. Cartography could evolve around predator territory as much as geography. Some places may literally be marked on maps as regions where humans do not return. Warfare changes too. Ancient armies in our timeline fought mainly against other humans. But in this alternate world, military strategy may revolve partly around surviving environmental threats larger than either side. Imagine fortresses built not only to resist invasion, but to withstand giant animals attracted by noise, blood, or movement. Cities may include elevated districts unreachable by large creatures. Bridges become narrow and defensible. Entire civilizations may avoid building near migration corridors despite fertile land, because the risk never disappears completely. Human expansion slows because ecosystems themselves resist it physically, and perhaps that changes humanity psychologically in ways difficult to measure. Modern civilization often treats nature as scenery or resource, but humans sharing Earth with dinosaurs may never fully separate themselves from ecological reality. Survival remains visible, fragile, immediate. There is another deeply unsettling possibility hidden beneath this coexistence. Dinosaurs themselves may adapt to humans over time. In our world, many animals already change behavior around civilization. Urban foxes become bolder. Ravens exploit traffic. Wolves study human patterns carefully. Some predators even learn to avoid hunters selectively. Now imagine dinosaur descendants evolving alongside humans for tens of thousands or millions of years. Certain species may become specialized around human environments, scavengers following settlements, intelligent omnivores exploiting food storage, ambush predators learning road systems and migration habits. Coexistence does not necessarily produce peace. Sometimes it produces more efficient conflict. Entire human cultures may evolve under constant evolutionary pressure from predators adapting to them in return. And yet, despite all this danger, humans might still find beauty in such a world. Children raised beneath enormous prehistoric skies may see dinosaur migrations, the way people in our timeline admire whales or northern lights. Giant feathered creatures crossing distant valleys at sunrise could inspire art, music, religion, and storytelling unlike anything in human history. Entire calendars may revolve around ancient migration cycles. Festivals may celebrate the return of massive herbivore herds after winter. Hunters may study dinosaur behavior with almost spiritual respect, because understanding these animals means understanding survival itself. Human civilization could become smaller, slower, and more ecologically aware, precisely because it never fully escapes nature's control. Technology may advance differently too. Instead of rapidly expanding industrial systems consuming entire continents, human societies may remain geographically cautious. Dense urbanization becomes dangerous in predator-active regions. Massive highways cutting through wilderness attract ecological instability constantly. Some technologies may focus less on domination and more on concealment, detection, and adaptation, quiet movement, elevated architecture, environmental sensing, defensive engineering. Humanity's greatest inventions might revolve around surviving inside the dinosaur world rather than replacing it. And somewhere beyond the walls of ancient human settlements, beneath humid forests, glowing with insects and drifting fog, creatures descended from Earth's oldest dynasties continue moving through darkness older than humanity itself, reminding every civilization that no matter how advanced humans become, they are still sharing the planet with beings that were ancient long before the first human story was ever told. If dinosaurs never disappeared, the modern Earth would not simply look like our world with a few giant reptiles added into the background. almost every part of civilization, geography, technology, and even human psychology would likely develop along a completely different path. The deeper you follow the chain reaction started by one asteroid missing the planet, the more unsettling the realization becomes. Modern humanity depends on an enormous number of invisible assumptions about safety, stability, and control. We assume highways can cut across continents uninterrupted. We assume coastlines belong to cities rather than giant animals. We assume forests can eventually be cleared, rivers redirected, ecosystems managed, and dangerous predators pushed into isolated reserves. But on a dinosaur Earth, those assumptions may never fully become true. The planet would remain physically dominated by ecosystems far larger and more resistant than anything humans learned to control in our own timeline. Even the shape of cities could change dramatically. Modern urban centers depend on massive transportation networks connecting millions of people through roads, railways, ports, and electrical systems. But imagine building those systems across landscapes, still occupied by giant migrating herbivores or intelligent apex predators. Highways crossing ancient migration corridors may become permanently dangerous or impossible to maintain. Entire regions could require elevated transport systems protected from animal movement below. Some settlements may remain enclosed behind defensive architecture resembling fortified ancient cities rather than open modern suburbs. Dense forests may survive much closer to human population, simply because clearing them completely becomes too expensive or dangerous. Night travel outside protected areas might remain rare even in technologically advanced societies. The emotional atmosphere of civilization changes when wilderness never truly retreats. There is also the question of population size. Human civilization expanded rapidly partly because industrial agriculture allowed enormous food surpluses. But large dinosaur ecosystems may continuously compete with agriculture for land, water, and stability. Massive herbivores migrating seasonally across continents could devastate crops the way locust swarms once terrified ancient civilizations, except with animals weighing several tons each. Predatory species adapting around human settlements may force populations into highly defended regions rather than open expansion across entire continents. Human numbers may remain far lower than they are in our world, simply because Kit's Earth stays biologically crowded with ancient competitors. In a strange way, modern humanity's explosive growth may only have been possible because most large prehistoric ecosystems collapsed long before civilization emerged. Technology itself may evolve more cautiously. In our timeline, industrialization accelerated because humans increasingly separated themselves from direct ecological pressure. Machines replaced physical labor. Firearms reduced predator threats. Fossil fuels powered expansion into environments once difficult to survive. But on a dinosaur Earth, technology may focus less on convenience and more on survival within unstable ecosystems. Detection systems, reinforced architecture, environmental monitoring, silent transportation, elevated infrastructure. Human engineering could become deeply defensive rather than aggressively expansionist. Some regions of the world may remain biologically uncontrollable, even with advanced technology. Dense prehistoric forests, swamp systems, and isolated mountain ranges could continue supporting ancient predator population, impossible to eliminate fully without catastrophic ecological consequences. Modern governments may treat certain territories almost like nations belonging to another form of life. Air travel may look different too. In our world, the skies belong mostly to machines and birds. But surviving descendants of pterosaurs or giant avian dinosaurs could make low-altitude flight extraordinarily dangerous in some regions. Airports may require massive protected zones. Flight paths could avoid migration routes. Some aerial predators may adapt to artificial light or urban heat signatures over time. Even ocean travel changes in a world where giant marine reptile lineages survive and continue evolving. Shipping lanes might avoid entire coastlines during breeding or migration seasons. Offshore cities may require reinforced underwater defenses. Deep oceans, already mysterious in our timeline, become even less understood when large prehistoric predators still dominate remote marine ecosystems. And despite all of this danger, there is a haunting possibility that Earth itself may actually appear healthier from space. Modern humans have reshaped forests, climate systems, rivers, and extinction rates at extraordinary speed. A dinosaur-dominated planet may slow human expansion enough to preserve enormous ecosystems that vanished in our own history. Vast wetlands remain untouched. Continental forests stretch across regions now covered in cities. Animal migrations continue on scales almost unimaginable today. Atmospheric carbon cycles may function differently beneath larger, untouched ecosystems. Biodiversity could remain astonishingly high because humans never gain total control over the biosphere. In our timeline, humanity became the dominant geological force on Earth. In theirs, humanity may remain only one force among many. That changes philosophy as much as survival. Human cultures in this alternate world may never fully believe nature exists to be conquered. Religions, politics, architecture, and science all develop beneath the constant reminder that something older and physically stronger still shares the planet. The wilderness would not be viewed as empty land waiting for development. It would remain an active living presence capable of pushing back. Some societies may worship certain dinosaur species. Others may organize entire economies around avoiding migration zones or predator territories. National borders could shift according to ecological movement rather than human politics alone. Wars between human civilizations may even pause seasonally because enormous animal migrations make campaigns impossible during certain months. And perhaps most unsettling of all, humans themselves may evolve psychologically in response to this world. Boom. Modern people are accustomed to constant noise from machines, lights visible through the night, and environments engineered for human comfort. But on a dinosaur Earth, silence may become deeply meaningful. Distant sounds in darkness matter. Forest movement matters. Weather patterns matter. Ancient instincts. Humans largely buried beneath civilization may remain permanently active. Children grow up learning predator calls alongside language. Architecture prioritizes visibility and escape routes instinctively. Entire cultures become experts at reading landscapes because survival still depends on understanding what lives beyond the walls. In some ways, humanity might become more connected to the natural world precisely because it never fully escapes it. There is another possibility that scientists occasionally discuss quietly when imagining alternative evolutionary histories. If dinosaurs continue evolving intelligence alongside humans, then modern Earth may contain multiple advanced species competing culturally and ecologically at once. 2. Not necessarily civilizations with skyscrapers or technology, but socially complex non-human lineages capable of sophisticated adaptation. Humans would no longer view intelligence as uniquely theirs. That realization alone could reshape philosophy, religion, ethics, and science beyond recognition. The idea of human exceptionalism becomes difficult to maintain when another ancient lineage survived long enough to develop comparable behavioral complexity independently. And somewhere beyond the boundaries of human cities, across forests thicker than anything left in our world, and coastlines still ruled by giant shadows, moving beneath storm-dark water, the descendants of creatures once hunted by Tyrannosaurus rex continue thriving under moonlight and rain, reminding humanity every day that Earth never truly became ours alone. 66 million years ago, somewhere far beyond Earth, a piece of ancient rock drifted silently through space. It had no intention, no purpose. It was not aiming for dinosaurs or planning the future of mammals. It was simply following gravity across the darkness of the solar system, moving through an emptiness so vast that human language struggles to describe it properly. And yet, that drifting object may have changed everything about who we are, every city ever built, every human memory, every language, religion, empire, and dream. The deeper scientists study Earth's history, the more unsettling the conclusion becomes. Human civilization may not be the inevitable result of evolution at all. It may be the outcome of one catastrophic accident that temporarily cleared the planet for us. Before the asteroid arrived, dinosaurs had already dominated Earth for over 160 million years. That number is so enormous. The human mind almost stops processing it emotionally. Modern humans have existed for only a tiny fraction of that time. Recorded history covers mere thousands of years. Industrial civilization only a few centuries. Dinosaurs were not a brief phase in Earth's story. They were one of the defining ages of life itself. Entire ecosystems evolved around them. Forests adapted to giant herbivores. Predators refined their hunting strategies across millions upon millions of generations. Oceans, climates, migration patterns, and food chains all operated inside a world fundamentally shaped by dinosaur dominance. And then, in geological terms, it ended almost instantly. The asteroid struck near what is now the Yucatan Peninsula, releasing energy beyond ordinary comprehension. Shockwaves traveled across continents. Forests ignited. Molten debris rained from the sky. Massive amounts of sulfur and dust entered the atmosphere, blocking sunlight and collapsing food chains worldwide. Plants died. Herbivores starved. Predators followed. Earth entered a biological crisis so severe that roughly 75% of species disappeared. The planet itself survived, but the structure of life changed permanently, and hidden inside that destruction was an opportunity mammals had never possessed before. It is tempting to think humans would eventually appear, no matter what happened. After all, mammals already existed before the extinction event. Some were intelligent, adaptable, and capable of surviving difficult environments. But evolution does not guarantee outcomes. Dinosaurs themselves survived and diversified successfully for far longer than mammals ever have. If the asteroid misses Earth, the ecological doors mammals later expanded into may never open at all. Primates may remain small, nocturnal creatures hidden in forests. Human-level intelligence may never evolve. Civilization may never begin. Somewhere across another version of Earth, the descendants of dinosaurs may still rule landscapes. humans never get the chance to build upon. That realization changes the emotional feeling of human history completely. We often talk about humanity as though civilization represented destiny, as though consciousness, cities, technology, and space travel were always waiting to emerge eventually. But Earth's fossil record tells a colder and stranger story. Survival often depends on timing more than superiority. Tiny mammals survived the extinction, partly because they were small, adaptable, and capable of hiding underground or eating varied food sources during ecological collapse. In another environment, those same traits might have kept them permanently insignificant instead. Evolution rewards whatever survives immediate conditions, not whatever seems most impressive later. There is something deeply humbling about that. Human beings tend to see themselves at the center of existence because consciousness naturally frames reality around itself. But the universe shows no obvious signs of designing Earth specifically for us. Dinosaurs dominated the planet successfully long before humans existed. If the asteroid never strikes, they may continue dominating it indefinitely. In fact, from a purely evolutionary perspective, dinosaurs were arguably more successful than humans so far. They survived for immense geological timescales without triggering the rapid planetary instability. Modern civilization has already begun causing through industrialization, deforestation, pollution, and climate change. Humanity's control over Earth may ultimately prove brief compared to the age that came before it. And perhaps that is why the asteroid story feels so haunting. It reveals how fragile the path toward human existence may actually have been. Scientists still debate important details about the extinction itself. Some research suggests volcanic eruptions in India, known as the Deccan Traps eruptions, were already stressing ecosystems before the asteroid arrived. Others argue the asteroid alone caused the overwhelming collapse. Some believe certain dinosaur groups were declining regionally, while others appear healthy in the fossil record right up until the end. But despite these debates, the larger picture remains widely accepted. Without the extinction event, mammals almost certainly would not have inherited Earth in the same way they did. Humanity's rise depended heavily on catastrophe, and catastrophe itself often depends on chance. One of the strangest details is that the asteroid did not merely hit Earth. It struck one of the worst possible locations. The impact zone contained sulfur-rich rock and shallow seas capable of launching enormous quantities of climate-altering material into the atmosphere. Some scientists have argued that if the asteroid had struck deeper ocean or different geological formations, the extinction may have been far less severe. In other words, the exact location mattered immensely. Earth's future may have depended on a collision point separated by only hundreds of miles. Entire civilizations yet to exist balanced unknowingly on geography, chemistry, and timing inside a single afternoon from deep time. And perhaps somewhere else in the universe, other planets experience different outcomes entirely. It is difficult not to wonder about that possibility. Across billions of stars, there may be worlds where asteroid impacts never arrived when they needed to, where ancient reptilian ecosystems continued evolving uninterrupted for hundreds of millions of years. There may be planets where intelligence emerged from descendants of creatures humans would recognize as dinosaur-like, or perhaps intelligence never emerged there at all because evolution found no reason to produce it. Earth's history suggests consciousness itself may not be guaranteed. It may be one rare experiment among countless silent worlds filled only with forests, oceans, predators, storms, and instinct moving endlessly beneath alien skies. The more we understand extinction, the less permanent humanity begins to feel. Dinosaurs once appeared unstoppable, too. They ruled Earth longer than mammals have even existed. Yet one cosmic event erased their dominance permanently. Human civilization now depends on technological systems, stable climates, global agriculture, and interconnected infrastructure vulnerable in ways ancient ecosystems never were. The asteroid story becomes unsettling, partly because it reminds us that no species remains untouchable forever. Earth changes. Space remains dangerous. Extinction is not abnormal in the universe. Survival is. And still, despite all of this uncertainty, there is something strangely beautiful hidden inside the accident. Humanity exists because life continued adapting after unimaginable catastrophe. Tiny mammals survived darkness, cold, fire, and ecological collapse long enough for evolution to continue experimenting. Eventually, those experiments produced creatures capable of looking backward across deep time and ask us impossible questions about their own origins. Tonight, somewhere beneath the quiet glow of satellites crossing the modern sky, human beings lie awake wondering about dinosaurs, asteroids, extinction, and chance. That alone is extraordinary. Because if one drifting rock in space arrives slightly earlier, slightly later, or misses Earth entirely, there may be nobody here to wonder about any of it at all. Thanks for spending this time exploring the ancient world with me tonight. If you enjoyed this journey, don't forget to subscribe to Sleepy Earth channel for more relaxing mysteries and prehistoric documentaries. 2. Leave a comment below telling me what topic you'd like me to explore next. And wherever you are in the world tonight, I wish you a peaceful night and good luck.